All right, guys, so this is the video for 12.2. And in this video, we're going to talk about independent and dependent events. Okay, so these are very different and they both have different formulas when we come to statistics. So independent events are two events in which the occurrence of one event does not affect the occurrence of another event. So suppose we are rolling two different die. Okay, so we roll the first die. Now, what we get on that first die has absolutely no effect on what we roll on the second die. Okay, so that would be an example of an independent event. Okay, dependent event, on the other hand, are when two events in which the occurrence of one event does affect the occurrence of another. Okay, so supposedly we're doing a drawing. We're pulling names out of a hat. And so we draw our first name out of the hat, and we read it, and that person wins a prize. And then we pull another one, but we don't put that same slip back in. That would be a dependent event because on that second pull, there's not as many names in the hat that can be drawn. So we'll do some examples and it'll make more sense. All right, so let's look at example 1. The first example is that we're rolling two 6-sided dice. Okay, so this would be an independent event. And the reason it's independent is because what we roll on the first die has no effect on the outcome of the second die. Okay, so that would be an example of independent. All right, so on B, 6 pieces of paper number 1 through 6 are in a bag. 2 pieces of paper are selected at one time, or selected one at a time, sorry, without replacement. Meaning, I pick a number, I don't put it back in, and I pick another number. Okay, this would be an example of a dependent because the second pull is affected by the outcome of the first. Right? When we pull the second time, there's not as many slips of paper in there, and therefore the probability of pulling a certain number is different than it would be the first time. All right, so I want you to do 2A and 2B on your own. And then we'll go over them. So read through the scenario and ask yourself, the second time around, does what we get on the first time affect the second time at all? All right, so in question A, it says a student's taking a quiz randomly guesses the answers to 4 true or false questions. Determine whether guessing question 1 correctly and guessing 2 correctly are independent or dependent events. Okay, well, these would be independent events. That's what you should have gotten, because whether we chose question 1 correctly or incorrectly has no effect on whether we chose question 2 correctly or incorrectly. Okay, now let's look at B. It says a group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. Okay, now here's our keywords here. We're choosing different students. So we're going to choose a student. That student can't be picked for the next one. Okay, so that would be dependent because what happens the first time does affect the second time because you can't pick that same student. All right, so we have some formulas now that we're going to use to find the probability of dependent and independent events. Okay, so the probability of A and B when they are independent events is just the probability of A times the probability of B. Okay, so the probability of A and B is equal to the probability of A times the probability of B. That's for independent events. Okay, for dependent events, it is a different formula. Okay, for dependent events, the probability of A and B is equal to the probability of A times the probability of B given A. Okay, so this is said in words, the probability of B given A, okay? Or the probability of B knowing that event A already happened. All right, let's look at example 3A here. It says, as part of a board game, you need to spin the spinner, which is divided into equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. Okay, so first of all, we want to think, are these independent or dependent events? Okay, these would be independent events. Okay, because what we roll in the first time, so say we roll a 1, that doesn't change, that doesn't have an effect on what we roll the second time. Okay, they're two totally different spins. We can roll the same thing more than once if we need. So because they're independent events, we would use the formula, the probability of A and B is equal to the probability of A times the probability of B. Okay, well, let's think of the probability as A, B the probability that we get a 5 on our first spin. So the probability that we get a 5. And then we can let the probability of B be the probability that we get greater than 3 on your second spin. Okay, so if I just do these separately, okay, the probability of us getting a 5, well, there's 1 5 and there's 8 total sections, so this would just be 1 out of 8. Okay, the probability of us getting a number more than 3 would be if we got a 4 or a 5 or a 6 or a 7 or an 8. Well, that's 5 out of 8. Okay, so I could say the probability of A and B are 5 and greater than 3 equals the probability of 5 times the probability of greater than 3, which is the probability of 5 we found is 1/8. Probability of greater than 3 we found is 5/8. So 1/8 times 5/8 is just 5/64. And that's our answer. All right, so let's look at example 3B now. It says a bag contains 20 $1 bills and 5 $100 bills. You randomly draw a bill from the bag, set it aside, and then randomly draw another bill from the bag. Find the probability that both events A and B will occur. So event A is the first draw is 100, and event B is the second draw is 100. Okay, so we want to know first, is this a independent or a dependent event? Okay, this would be dependent. Okay, because our second draw is affected by our first draw, because if we pull a 100, our first draw, there's going to be 1 less $100 bills on our second draw in there to draw. Okay, so I'm going to go ahead and write a visual. So I have 20 $1 bills. So I have a $1 bill, 2, 3, 4, 5. There's my 5 $1 bills. Here's another 5. Here's another 5. Here's another 5. Okay, so there's 20 $1 bills, and then there's 5 $100 bills. Okay, so because it's dependent, we're going to use the probability of A and B. That's going to equal the probability of A times the probability of B given A. Okay, so the probability of B, knowing that A already happened. Okay, so the probability of A is the probability that the first bill is 100. Okay, well, let's draw a $100 bill. That's 1, 2, 3, 4, 5. 5 out of, there's 25 total bills, or just 1/5. Okay, so say we draw this 100. Done. 1 in 5 chance we draw a $100 bill. Okay, now the probability of B is going to equal, we don't have 5 $100 bills left. We now have 1, 2, 3, 4 $100 bills left, and we don't have 25 choices anymore. We have only 24, right? Because one of these hundreds is gone. Okay, it does affect the second time. So 4 over 24 is 1 over 6. Okay, this is the probability of B given A, not the probability of B. Probability of B knowing that A happened, sorry. Okay, so now the probability of A and B is the probability of A times the probability of B given A, which is just probability of A is 1 over 5, times the probability of B given A, 1 over 6, gives me a 1 out of 30 chances that I pull 2 $100 bills. All right, I want you to try to do this example on your own. So we're going to do 2 ways. The first way, we're going to do it with replacement. Okay, so we're going to draw a card, see what it is, put it back. Draw another card, see what it is, put it back, okay? So we're randomly selecting 3 cards from a standard deck of 52 playing cards. So we're going to select 3. There's 52 total in a deck of playing cards. What is the probability that all 3 cards are hearts? Okay, if you don't know, there are 13 hearts out of the whole deck, which is 52 cards. Okay, so I want you to find 1, what's the probability that all 3 are hearts when we replace each card before selecting the next? And 2, when we don't replace it, okay, and I'll give you a hint. One of these is independent, one is dependent, and depending on which one it is, depends on which formula you use. So go ahead and try this one on your own, and then we'll go over it. All right, so on the first one, when we replace it, that is independent because we have the same probability the second time around than we did the first time around. The same probability the third we did the second. So we're just going to take the probability that's heart, which is 1/4. That's going to be the probability of A, pulling a heart first. That's going to be the probability of pulling the heart second and pulling a heart third, because the first draw or the draw in front of the other doesn't change it. So it's just 1/4 times 1/4 times 1/4, which is 1 over 64, which is about 0.015, or only 1.5%, which is not very good. Okay, now things get tricky when we don't replace it. Okay, so the probability of pulling a heart first is 13 over 52, which is just 1/4. Okay, we don't put it back. So we no longer have 13 hearts left, we have 12. We no longer have 52 cards in the stack to pull from, we have 51. Okay, so the probability of pulling a second heart is 12 over 51. And then same thing with the third. Now we no longer have 12 hearts in the deck, we have 11. We no longer have 51 cards in the deck, we have 50. So the probability of pulling a third heart is 11 over 50. Okay, so when I multiply all those together, I get 0.013, which is less than if we replace it. Both are very, very small, but less when we replace it.